Hello, everybody. You're going to be looking ahead to our next unit while the people in the classroom are taking their test. This next unit is called Unit 1B. Remember, Unit 1 is all about quadratics, and quadratics is a huge unit. So instead of giving you one gigantic unit, we've split it into multiple parts. So the first part was quadratics. What are they? How do we graph them? And how do we find solutions by looking at the graph? This unit is still quadratics. All of Unit 1 is quadratics, but it's how do we find solutions or how do we solve them using other methods? Okay, so let's start with what is a quadratic, just to make sure you recall. A quadratic is an equation where the biggest exponent for your independent variable, for your x usually, is a 2. Okay, so it's going to have an exponent of 2. Y equals x squared is the parent function of a quadratic. It's the basic model, the one that doesn't have any stretches or shrinks. It hasn't been slid around. It hasn't been flipped. So y equals x squared is the basic model. Now we learned how to graph a quadratic and we learned how to find its solutions. Remember, finding find solutions, that's the same as solving. So if we are solving, we're finding solutions. We found solutions in the first unit, 1A, by looking at the graph. Okay. Now what are solutions? Remember, they are x-intercepts, roots, or zeros. So in that last unit, we found x-intercepts, which are solutions, looking at the graph and looking to see where it crossed the x-axis. Those points where it crosses the x-axis are called x-intercepts, and those are the solutions. But we can also find solutions other ways. We can find them algebraically. If you think about algebraic methods as being ways that just move around or manipulate variables and numbers, okay, so that's probably the best way to think of it. And there are different ways of algebraically finding solution. There's factoring, taking square roots, completing the square and quadratic formula. The only one we're going to do in this unit 1B is factoring. So we are going to learn a second way now to find the solutions to a quadratic. Remember, a quadratic is an equation where x is squared, no higher exponent for x, just a 2. We've already found the solutions one way. That was by looking at the graphs and looking for the x-intercepts. Now we're going to find solutions by factoring. But before we can get into factoring, we got to do some other stuff. We got to first learn some vocabulary to make sure we talk about everything the same way. So we got a list of definitions here. And the first one is a monomial. Now there's a lot to this one, so let's make sure we understand it. First of all, it's an expression. So remember, an expression does not have an equal sign. An equation has an equal sign. So it's an expression. Now it could have a number, could have a variable, or it could be a combination. Okay? It could be a product of them. And it has to follow some specific rules. It cannot contain a variable under a radical. By the way, this is supposed to look like a radical. Okay, so it should look like a radical, not a check mark. So it cannot have a variable under a radical, cannot have a variable raised to a negative power, and it cannot have a variable in the denominator of a fraction. So it has to follow those 3 rules. We will be going back to those as we decide whether or not we have a monomial to make sure it doesn't break any of those rules. Now, there are different types of monomials. There's a monomial that has no variables, okay? And that is called a constant. think about constant. That word means never changes, right? So if it has no variables, that means there's never any changes. And so if it never changes, it's a constant. Okay, so for example, 12 or negative 123, those would be constants. Now, when you look at a monomial that has a number and a variable, the number that's being multiplied by the variable is a coefficient. It's hard to read that, isn't it? Okay, so for example, the coefficient of 4x squared. The number is what we're looking for, the coefficient, so it's a 4. And then there's a term called the leading coefficient. And it's the coefficient of the first term, but only if they're in decreasing order of exponents. So you gotta make sure you put a little star by that to make sure you don't miss it. It has to be in decreasing order of exponents. In other words, and we'll look at this and I'll mention it then too, but it's going to be the coefficient of the term with the biggest exponent. Okay, so I'll talk about that again, but that would be a leading coefficient. So fill in this chart. We want to decide if we have constants and also what the coefficient is. So let's look here. We've got a monomial. It's 2ab cubed. Is that a constant? Does it have a variable? Yep. So it would not be a constant. The coefficient is the number, not the exponent, but the number being multiplied by the variables. So it's a 2. All right, let's look at the next row. 6. Is that a constant? Does it have any variables? Doesn't have any variables, so that means it never changes. So yes, it is a constant. Okay? The coefficient is actually the 6. Coefficient is being multiplied by a variable, but the variable is going to be equal to 1, right? Okay, so this is 6 times 1. So how can I make 1 a variable? Well, I could call it x to the some power. What power can I raise x to so that it's 1? 0. So 6 times 1 is 6 times x to the 0. So 6 is the coefficient. Last row, is this a constant? Does it have any variables? Sure does, so it is not a constant. What's the coefficient? What's the number being multiplied by the variables? Negative 4. You're going to have practice on this for your homework too. All right, now a monomial or a sum of monomials is a polynomial. Now notice, you all have learned, I'm sure, that poly means many, right? So you think, oh, it's got to be a lot of monomials together, but it doesn't. It could just be one. So it's either one or more monomials. Okay, could be just one. And notice it says sum. So these are going to be added together. But remember that subtraction really is just adding the opposite. So it means added or subtracted. So it's one or more monomials added or subtracted together. The monomials that make up a polynomial are called terms. A polynomial with 2 terms, okay, remember this, guys? Think of 2 terms, think of 2 wheels, binomial, a bicycle. three terms, think of some kind of bike with three wheels, would be a trinomial, right? If you think about it, have you ever heard of a monocle? A monocle is one of those things people used to wear where they put one glass in their eye and I guess they'd squint a little and hold it in. So monomial would be like a monocle. So it has only one. Monomials that have the same variables with the same exponents are like terms. And you've done like terms over and over and over. All right, so let's look at a chart where we're going to practice, okay? So we're going to practice deciding if it's a polynomial, which really just means is it a monomial, okay? So go back to the rules. We're going to check the rules here. And then if it is a monomial, then the number of terms and also what is its name. So 1 over a, we're going to check the rules. So that rules were up top. And one rule is you cannot have a variable in the denominator of a fraction. See this A in the denominator? So that means it is not a polynomial because we have the variable in the denominator. Since it is not a polynomial, we don't worry about number of terms. We don't worry about name. They won't apply. Okay, so number of terms and name do not apply if it's not a variable, or excuse me, a polynomial. All right, the next one. We got 1/2 x to the fourth y to the third minus 23x squared y. Does it break any of the rules? All right, there isn't a variable in the denominator. Doesn't break that rule. There isn't a variable under a radical, so it does not break that rule. And there isn't a variable with a negative exponent, so it doesn't break that rule. Since it doesn't break any of the three rules, it's a monomial or a polynomial. The number of terms, well, remember, they are going to be added or subtracted together. So what I recommend is that you highlight or circle everything but the pluses and minuses and see how many things that you've highlighted or circled. So see, I did not highlight this minus in between. I just highlighted the two terms. So it has 2. Now, 2 terms means binomial. All right, the next one, the 3 rules. No variable under the radical, no variable in the denominator, and no variable with a negative exponent. So it is a polynomial. How many terms, though? Ooh, careful, guys. Because they are like terms, we can add them together. So there's really only one term. So it's the monomial. Monomial, remember the monocle. All right, now x to the negative 3. That breaks one of the rules, okay? No negative exponent. And remember, if you put no in that blank, then you put x's in those. And 2, and then a square root of x. That's also a no, okay? Because you got the variable under square root. So I put a no there, so I put x's there. So that's the vocabulary. Let's talk a little bit about the adding or subtracting expressions. Remember that we can only combine like terms. And so we're going to practice a little bit here. I recommend that you go through and highlight or underline like terms before you get started. So if I look at number 1, like terms will have the same variable to the same exponent. So see how these both have an x, and neither of them has an exponent other than the 1. So I'll be able to combine those and get 11x. And then there's also this minus 10, which doesn't have anybody to combine with. So it will stay separate. It's 11x minus 10. Now we will put our answers in order with decreasing exponents. We call that standard form. Remember I told you last unit that we have a lot of standard forms. We talked about standard form of a quadratic, but now we're just going to talk about other standard forms. So let's look at number 2. We have this 5x squared and this 2x. And then we have a minus 3x and a plus x. Notice that I do have to be careful with my signs. Whatever sign is right before my term goes with it. So signs go with terms, but it's always a sign right in front of the term. So if I combine my 5x squared and my 2x squared, I get 7. But remember, guys, we're just adding. And when we add, that doesn't affect exponents. Exponents tell us about multiplication. They do not tell us about adding. So exponents do not change when you add. I'll say that again. Exponents do not change when you add because exponents tell you about multiplication. So we do not change our exponents. So that's what I get when I combine the first two. And then when I combine the ones that I put in black boxes, I get negative 2x. And then my last thing I should do is check that my exponents are in decreasing order. I have a 2 first, and then I have that 1 that's implied. So yes, those are in decreasing order. Number 3. Now notice that I have parentheses here. That's because I want to be able to tell that I have a polynomial here and another polynomial here. But because I'm going to add them, it's not going to make any difference what comes after or what comes in the parentheses. Adding 2 polynomials is just going to be combining like terms. So now I'm going to do some highlighting since I've already done some underlining. So I've got some cubes here, and then I have a squared, but I only have 1 squared. And then I also have some x terms. Okay, so let's start with the x cubed because I want these in decreasing order. So let's go ahead and start with these. Now notice again, the sign that's right in front of each term is what goes with it. And because there's a plus in the middle, I'm not doing anything special. I'm just combining a bunch of like terms. So I'm going to combine my 10x cubed and my 2x cubed and get 12x cubed. And then my green will come next so that I can keep them in order. There's nobody to combine that x squared with, so it will stay in x squared. And then I have a negative 5x and a negative 7x, which will give me a negative 12x. But now this is going to change. Now I see that I have a minus in between. And when I have a minus in between, that means I need to subtract all of the terms that are in this parentheses here. Okay, that's why they put parentheses around it to let me know I need to subtract the entire set of parentheses. So let's stop and think for a second. Remember when you were in school a few years back and you learned something like 4 minus 7? And you're like, what am I supposed to do with that? 7's too big to subtract. Your teacher probably taught you that subtraction is just adding an opposite. Okay, so remember, when you subtract, you just add an opposite. So let's go up to this one and see if we can use that idea. Okay, so we're going to add an opposite. But then look, guys, look. I'm going to add the opposite of 2x. So that means I'm going to add negative 2x. And I'm going to add the opposite of 8, which I'm going to make a negative 8. So when I do this problem, okay, if it's minus with parentheses, then I'm going to change the minus to a plus, and then I'm going to take the opposite of every term in the parentheses. So for number 4, I have now taken the opposite of the 2x and the opposite of 8. So I can now figure out what my like terms are. I've got x squared and a negative 2x squared. And I have a negative 5 and a negative 8. So when I combine these, 3x squared and negative 2x squared gives me x squared. Negative 5 and negative 8 gives me negative 13. So I'm going to do a couple more of examples of just those. And then when you work on your homework, you can always send me a reminder if you have a question. So we're going to look at numbers 5 and 6. I'm going to go ahead and put the answers in for all of the rest of them into my content library so you can check them. But I'm not going to make you listen to me talk about it anymore because you're probably getting just as tired of hearing about it as I am talking about it. All right, so number 5, we're going to do it because it has a minus in between. So note, I'm going to make the minus a plus. And then I change the sign of every single term in the parentheses. So the plus 5 becomes a minus 5 and the negative 6 becomes a positive. See how I changed both of those? Everything in the parentheses gets changed. Now I'm going to highlight my like terms. And I don't have anything to go with the x squared. I do have a couple of x's. Oops, pick the color. And I do have some constants. With that color, as you can really see, I made that a plus. Okay. So x squareds didn't have anything to go with them, but they do need to come, just the one, and it's going to come first. Then a negative 4x and a negative 5x give me a negative 9x, and a plus 6 and a plus 6 gives me a plus 12. Let's do number 6 the same way. And then again, I will put all of the rest of it in the content library, and you can look at it, or you can go ahead and start your homework. So on this one, I'm going to change the minus in between to a plus, and I'm going to change every sign in the parentheses. So I need to change both of those. I have that x cubed term, and I have an x cubed term here. I have an x term here and an x term here. So when I combine those, I get x cubed minus 2x cubed is x, just 1 x cubed, and an x plus a 13x is a 14. Let me point out something real quick, guys. Number 9 down here. See how there's a plus in between here? I don't change. I don't want to make it a negative. Okay, that just makes life more difficult. I like having pluses in between. So I don't change pluses. I only change minuses, right? So here is the rule for that, and that will be in your content library as well. All right, so you are going to do this homework here, which is page 3. Feel free to send me a reminder if you have a question and go back to the content library to see how this all works. Take care. Love you. See you soon.